Hey folks, here we are on page 175, number 11. We got the length of time in minutes to mend a bicycle with normal distribution. The mean we don't know, the variance we don't know. We got the probability of x being greater than 30, we know that. And we also know the probability of x being greater than 20.9. You notice how we've got two things we don't know, and we've got two possibilities for making equations. This is a system of equations problem. So let's go ahead and spell out some of our stuff. X is normally distributed. We don't know either of these things. That's what we're trying to figure out. We know that we got the probability that X is greater than 30, and we know that that's going to be 0.1480. And then we also know the probability that X is greater than 20.9. We know that's going to equal 0.6228. All right, so let's take them one at a time. Let's go back and look at this one first. Let's make it standardized. So let's change it to a Z. And then what we're going to have to do is kind of figure out what we're looking at. Well, the probability is pretty small, only about 14%. So we know that the Z-score is on this side of the median. And unfortunately, it goes to the right. Our Z-scores go to the left. So it's not that hard to figure out that 0.852 is on the other side of my Z. So I'm going to do less than Z instead of greater than Z. And I know that that's going to be 852. I go to the table, and remember, I know the probability, and so I'm going to look inside the middle of the table. And then what I'm going to do is get this number. So let's go find it, 0.852. Trying to find the closest one. 850. All right, that's 1.04. Now, how much more do we need? Let's see. If we add 12 to that, 8 and 12 is 20. That'll be 8.852. So that makes our number is 1.045. All right, so now all we've got to do is multiply theta on both sides. And let's go look at our other one. All right, so we're going to do the same thing. Basically, we know we got to standardize this. We got to make it to a Z. So that's going to be 20.9 minus the mean we don't know and the standard deviation divided by the standard deviation we don't know. And let's take a look at this one. Okay, so here we know that 0.6228, that's all over here. So we know that the guy we're looking at is a negative number. And of course, we don't have negative numbers on our tables, but we do have positive numbers. And luckily, the normal distribution is symmetrical. So what we're going to do is go on the other side and pick the positive version of this that ends up being less than and 0.6628. Now when we find our number, let's go ahead and find it first. So let's see here, 0.6217. All right, that is, we need 28. So 17 plus 11, that gives us the 28, 6228, okay. So that gives us our number, 0.313. Now keep in mind, we just found the positive version. The guy we actually need is his symmetrical brother is negative. So when we rewrite all this stuff, we make sure we put negative 0.313. And then again, we're going to multiply both sides by theta and get our equation. Now, you notice how the other guy is set up pretty much the same. I'm going to multiply him by -1 and put him underneath. And so then when I add these two equations together, the mu's will be eliminated. So let's see, 20.9 minus 30, that gives us -9.1, equals, and then -1.358 theta. We divide both sides by -1.358, and we'll find out that our standard deviation is going to be 6.7. Now remember, we got to take the non-rounded version and multiply it back into one of the original equations to find out what our mu is going to be. And we'll find out that's going to be 22.99 or roughly 23. All right, thanks for watching. Hope that helped.